The tip of a one-link robot is represented as a position vector P, and that means it's a vector with the line on the top, with the arrow on the top, as shown in this figure. Find the x and y components of the vector if the length of P is equal to 8 and theta equals 60 degrees. And then we're going to do the same thing. We're going to write it polar. Actually, we can write it in polar right now because there's nothing to do to write it in polar. In polar, because I'm looking for r comma theta, I already know r comma theta because r is the same, again, as the hypotenuse of a triangle or the radius of a circle. I could say 8 comma theta is 60 degrees. I don't have to actually do anything to get it into r comma theta. To break it down into its component form, I have to say x and y. We have the sine, and we're using 60 degrees, is equal to y over 8. And that means that y is equal to 8 sine of 60 degrees. And honestly, when we do polar and vectors, we could just say y is equal to r sine theta and x is equal to r cosine theta. So sine of 60 degrees is square root of 3 over 2. So y here is 4 times the square root of 3. We have cosine of 60 degrees equals adjacent over hypotenuse, so x over 8, or we could say 8, x equals 8 cosine of 60 degrees, which is equal to 8. Cosine of 60 degrees is 1/2. X equals 4. All right, I have my x, I have my y, and now I just have to put it into the form they want, which is vector P is equal to 4i, because the x value goes with the I, plus 4 times the square root of 3j.